Okay, the height of a projectile shot vertically upward from a point 2 meters above the ground level with initial velocity of 24.5 is given to be this. Okay, so now it asks you to find the velocity at 2 seconds and 4 seconds. So we need to find, first of all, dh over dt, which is going to be 24.5 minus 9.8t. So 2 seconds and 4 seconds, all you have to do is replace with the t with 2. So 24.5 minus 9.8 times 2. Okay, at 4 seconds, you just have to replace it with 4. Okay, so this is the velocity we get, 4.9 meters per second. The positive represents it's going up. Minus 14.7, that represents it's going down. Okay, so part B. When does a projectile reach its maximum height? Okay, when the projectile goes up and when it starts to turn back down, right, at that point, that's the maximum height. So in other words, when dh over dt is equal to 0, it hits the maximum height. So let's set that 24.5 minus 9.8 t to be 0 and solve for t. So at 2.5 seconds, we hit the maximum height. What is the maximum height? For part C, you got to replace the original equation, the t with 2.5. And you get 32.625 meters. When does it hit the ground? Well, it hits the ground when h is 0. So let's set the original equations, which is 2 plus to 0. Okay, so you can just use the quadratic formula. T is equal to minus b plus minus b squared, so 24.5 squared minus 4a, a in this case is minus 4.9, c all over like that, and we get approximately 5.08 seconds. Okay, so we got you actually get one more value here with it, but it's going to be a negative value, and that's referring to, because the projectile motion started at exactly 2 meters, so you're going to get two answers algebraically, one here and one here. But we only care about this positive time, 5.08. Okay, and lastly, at what velocity does it hit the ground? Okay, so let's use this. Okay, this is the velocity, dh over dt. To find the velocity, you just have to replace the time with 5.08. And we get minus 25.284 meters per second. So that means again, the minus just represents it's going downwards.